Good morning. So my name is Schwegler. I'm working for Microsoft, and my team is working with startups and incubation labs among enterprises to create really innovative solutions. If I look back about the projects, a couple of the projects we did, many of them actually have machine learning in there or predictive analytics. And I thought I'm going to talk to you in the next 20 minutes about the rise of the machines or how machine learning can actually help you to create better solutions. But before I start, I would like to have a raised hand of who actually has a degree in computer science. That might be a little bit introductory, what I'm going to talk about. So this talk is predominantly for the people who haven't been introduced to this topic before. We actually use machine learning every day. Can you come up with a scenario where you just used this morning machine learning? Who is going to filter spam from ham? It's machine learning. It's not just good enough to search for the text of blue pill in your email, because you actually might have a conversation with your friend about the Matrix movie. So we actually use machine learning to classify, using algorithms, whether this email is spam or ham. Another great example are recommendation engines. So the way, for instance, Spotify or Amazon give you very accurate recommendations about either another product you might like or some music you would like based on your listening history is all based on machine learning as well. But it doesn't stop there. Think about predictive analytics. So making predictions based on a model. So wouldn't it be nice to basically have a model in place that allows you to ask, what's the probability of this visitor to my website that he actually is going to buy something? Or how can I actually cluster this user to make him buy something? For instance, at Bing, what we do, which I think is fairly interesting, we give you a probability of how much is our probability to think that a flight is going to increase in price. So over here you see, we say the probability is 80% that the flight will actually increase by a fare of $50 till it actually takes place. So that's a very, very common question in machine learning. You don't get a yes or no back, but you get a probability back. Something that's extremely hot, and a couple of projects we're doing in this area, is predictive maintenance. So fix stuff before it breaks. Just imagine you analyze the telemetric data of a car, and you correlate certain devices and control units, and you're suddenly going to realize that you can make predictions about certain failure in a car, and you can do proactive maintenance before a fatal error happens. Super, super hot topic. And then also, you can make predictions personal. Think about Google Now or Cortana. These prediction engines learn about you, your behavior, your likes, your dislikes. They start to understand that if you want to schedule a meeting, it's better in the afternoon rather than in the morning. Or if you ask for a restaurant recommendation, they can factor in your likes, dislikes, the likes and dislikes of your social network as well. So machine learning is everywhere, and I just believe that modern solutions, innovative solutions, should actually take advantage of it one or the other way. Because there has never been more data at your fingertip. We're all connected together in a cloud, And the Internet of Things allows you to work with telemetric data like we've never were able to do before. So for the rest of the talk, I'm going to cover an introduction to machine learning, so you understand the fundamentals of it. Then I'd like to introduce you to the data science workflow, which is basically the things you have to do if you do a machine learning project and want to take advantage of, for instance, of predictive analytics. And then last but not least, I will walk you through what it takes to create a recommendation engine. So I will actually show you how I built a movie recommendation engine. This is a definition of machine learning. Machine learning are algorithms and systems that improve their performance with experience. So experience is the key word here. We train these systems. The more we train them, the better they get. So what you see here is a training cycle, which is the yellow one, and the actual model in place. The data that we use to train the model and the data that we use to make a prediction is actually called features. They describe our domain. So we use these features, train our model using algorithms, and once the model is trained, we can use it to make predictions. I go into more detail fairly soon. But think about, we would like to classify chairs and tables. So we would have features such as, does it have a back? How many legs does it have? What's the height of the object? What's the square foot of the surface? And so on. Based on these features, the algorithm then can actually learn and hopefully classify these objects. But it can never say it's a chair or a table, because we didn't tell him what's a chair or a table. So if we now augment these features by basically saying, and by the way, this data set belongs to a chair, and this data set belongs to a table, it is able later on to separate chairs from tables. This type of input is called a label. And as you can imagine, having well-labeled data in a machine learning cycle is the hard bit to get. So features describe the domain. There can be income, age, education. It can be text. It can be numbers, but it also can have categories like, what's your education? Is it's a PhD, a master, a bachelor, and so on. Now, labels are features which describe the particular data set in more detail. So if we want to learn and recognize a man in a picture, we have to augment the pictures and basically tell, look, in this picture, there is a man. In this picture, there is a horse. In this picture, there is a cat. And that would be labeled data that we use to train the model. But even if you don't have labeled data, you can use machine learning to actually do unsupervised learning. What you can do is, you can, for instance, cluster the users of your website, or you can create associations between users. And you don't need to have labeled data to do so. If you actually have labeled data, that's what we call supervised learning. So many of the predictions that we do, they required labeled data because we're actually doing supervised learning. I talked about training the model. Now, this is really the classical thing that you have to do in machine learning. You have your data set, and then you have to split it into a training set and a validation set. Because you can only evaluate the performance of your model if you give him data that he didn't see before. If you're going to evaluate your model on data that you already used to train it, then obviously the accuracy is going to fairly high that it recognizes the man, the cat, or the horse. So what we do is we split the data into a training set and into a validation set. And then we train the model. We want it to learn about, our features and then use the labels to actually classify it. Once the model is trained, we use the validation data, use the trained model, and see what is the accuracy of our predictions. And that's where, for instance, if you have an accuracy which is extremely high, then most likely your model is overfitted, so it's actually geared towards a specific data set. Usually, your accuracy might be around 80 or 90%. As you can imagine, different tasks require different algorithms. And getting hand at these algorithms from time to time, not easy. But if you want to find similar companies, you would actually use clustering. So you would use a clustering algorithm. If you want to make predictions about a bike rental based on weather data and historical rental data, then you could use a regression tree. And if you would like to predict a credit risk, then that would be a decision tree. Now, there are many tools out there to do machine learning. The most popular language is definitely R. Mahout is part of the Hadoop ecosystem. And at Microsoft, we invest a lot in something that we call the Microsoft Azure Machine Learning. I call this from now on MAML. So let's have a look at the workflow. So what does it actually take if you want to take advantage of machine learning? First, you need to have a problem, and you need to be able to phrase a question. The question might be, does this picture have a cat in it? The question might be, what's the probability that this customer is going to buy on my website? Or the question might be, is this a good or a bad credit risk for me? So once you have your question defined, you then have to start and think about what is the data that provides a good proxy to actually build a model on it. Most likely, you also have to label that data. So you actually have to help and see, based on your weblogs, who actually bought something versus who didn't bought something. Once we have this data, we then start training the model. And that's a fairly iterative process. We check out with different algorithms, what are the results we're going to get? What's the accuracy? We score the model. And once we have something in place where we think that makes sense, we actually talk it more broadly with the business owners as well and really see whether this makes sense. There is something called the danger zone among data scientists, which means if you have the hacking skills and the domain skills, but you lack the statistical knowledge. Because ultimately, it is crucial that the data you use to build your knowledge, your model, is actually statistically relevant and accurate. If you're happy with the model, you can put this into production. So you basically create a web service where you can send your features, and you're going to get the prediction back. So you can incorporate this into your website. So let's do this now with a movie recommender. Our objective is to create a recommendation engine based on historical user ratings. That's how I want to build my recommendation engine. The data I need are a triple of the user, the movie, and their rating. What you see here is that I actually use a tool that allows me to see the statistical distribution of these values. You also see how many unique values I have. So using these type of tools help you to see whether a feature makes sense or not, and whether this is a good input into your model while you're actually training it. Then I want to build and train my model. In our scenario, what I'm going to do is I'm using an algorithm which is called Matchbox Recommender. This is an algorithm that Microsoft Research created, and it's for large-scale recommendation engines which take user preferences into account as well. And this is how this looks in MAML, so the Machine Learning Studio. On the very top, what you see is I load in my data, my training data. Then project column just means I drop everything from that data set except user, movie, rating. And then I make a split. I define, what goes into my training set, what goes into my validation set. And the stuff within the red box, that's actually training the model. The cool thing about MAML is that we do this all in the cloud. So all the compute capacity to run that stuff, to use that algorithm, is all done in the cloud. So once we have this model trained, we have to see whether the result is what we were looking for. I actually have a score module, as you see, and I have an evaluate model. So in the score model, you simply see that I get an item and a related item. So basically, one item is a movie ID, and then the recommended movie IDs. That's what you see up there. So I can evaluate this model and see whether it really performs the way I want. You also can get out some statistical numbers to see what's the accuracy of the prediction and the distance between the recommendations. The last thing to really take advantage of my recommendation engine is I have to replace these movie IDs with the movie titles. And once that is done, I literally just push it out as a web service. So I can call it with whatever language and platform I want. To do so, I just load the international movie database. I edit a little bit about the column names, and then I do a join for the item, and a join for the related item. And the output, as you see, is now movie name with my recommendations. So if you like Oblivion, then you might also like King Kong. That's the output of my model. It actually didn't take me longer than an hour to really create the whole thing, including publishing this as a web service. If you want to learn more about this, go to azure.com. We have a machine learning center there with some good tutorials about how machine learning works in general, but also very specific about MAML. In closing, just think about all the different opportunities you have where you can make predictions. Find a probability about a customer, a probability about a system failure, or clustering data. And once you have this, start to think about what's the question that you can ask, find your proxy data, start to train the model, evaluate it, score it, and then publish it. I truly believe that the barrier for using machine learning was never lower than yet, but also the opportunity that comes with it is just tremendous. So I hope you're just going to enjoy.